So exercise thermal physics, the first 28 questions I have solved. So I'll start with 29 onwards. So in this question, we have spirometer is a device used in medical tests to investigate breathing. The spirometer measures the volume of air enter and leave the lungs. As you can see, a patient is asked to breathe normally, take a maximum breath in and maximum breath out, then breathe normally again. The results are shown on the graph. As you can see, the volume of air which is taken in and breath out, that is shown. The lungs, in the lungs, the air was at a temperature of 37 degrees centigrade and a pressure of 1 exponent 5. Show that the number of the molecule which are expelled, number of air molecules expelled from the lungs between the maximum breath and the breath in and out is about 1 exponent 23. So we need the number of the particles and we have a temperature as well. So for which formula, first you will recall the formula, which formula we'll use? We'll use a general gas equation, PV is equals to N KT, where P is representing the pressure, V is representing the volume, which is there in the lungs, N is the number of the particles, K is a constant, and T is a temperature. So what can be done? What could be done? Like we can find the total number of the particles which are, the question is number of air particles expelled from the lungs between a maximum breath in and maximum breath out. So what we can do, we can find the number of the particles when it is breath in, and we find the number of the particles in, like the number of the particles which are in the lungs, because this is the volume of a gas in the lungs. So we can find the number of the particles which are present in the lungs when it is breath in, and then we find the number of the particles which are present in the lungs when breath out. And to know how many particles leave, we just take a difference of the two. Because when we take a difference of the two, we know how many particles are going out. I'll solve the question, but that is the concept behind the question. Is it clear? Or I can just take the difference in the volume directly, like when how much volume of a, because we need how much air is being expelled or how many particles are being expelled. So this is the volume of air which is present in the lungs when we breathe in or a patient breathe in, and this is a volume of air present in the lungs when he breathe out. So what we can do, there are two ways to do the same question. Like you can find how many particles are there in the lungs when it is breath in. Then you find how many particles are there in the lungs when breath out. And you can take a difference of the two particles, take a difference of the two number of the particles, and you know how many particles are being released. Or you can find directly substitute, instead of substituting volume here, you can substitute the change in volume. Like here, volume is V1. Here volume is V2. So you can substitute the change in volume multiplied by pressure divided by gas, the Boltzmann constant and the temperature. You can identify the number of the particles which are released. So we use this formula PV is equals to NKT. I'm doing it directly, like instead of using like finding first number of particles, second number of particle, directly I'm working out. So what is the pressure? According to the question, the pressure is 1.02 exponent 5. As you can see here, the pressure. What about the change in the volume? What is the volume here? It looks like 10 boxes equals to 1. Yeah, 10 boxes equals to 1. So each is representing 0.1. So this is 5.9 into 10 to the power minus 3. And this is 1.3 into 10 to the power minus 3. So what will be the change in the volume? So the difference in the volume, that is how much air is being released. So 5.9 into 10 to the power minus 3 minus 1.3 into 10 to the power minus 3. That will give us the change in volume. Divided by, because I need n, so divided by k. K is a fixed value. In exam, it will be given the constant, which is 1.38 into 10 to the power minus 23. That's a fixed value for a Boltzmann constant. And then the temperature is given in degree centigrade, but as I mentioned, whenever you substitute the temperature, it should be in Kelvin. So the temperature is 37 degrees. I have to convert into Kelvin. So add 273. So this will convert and will give us how many particles are released. What's the answer for this? When you simplify? So it will be about 1.1 into 10 to the power 23. That is the total number of the particles which are released. Is it clear, this one? Any doubts? Then we move on to the next question, the next part of the question. That is, the question is calculate the total kinetic energy of air molecule expelled from the lungs between maximum breath and the minimum breath. So we know the kinetic energy, which is half mv square for the particle, is equals to 3 by 2 kT. That's a formula. So half mv square is a kinetic energy. So I need a kinetic energy. So kinetic energy will be equals to 3 by 2 K into T. So this will be 3 by 2. K is a Boltzmann constant, which is again having a fixed value, which is 1.38 into 10 to the power minus 23 multiplied by the temperature at 37, so at 273. This is for one particle, like kinetic energy for a one particle. If you read the question, what they ask us, they ask the total kinetic energy of the air particle. Total. This will give us the kinetic energy of one particle. I need the total for total. So what I should do after getting a kinetic half mv square 3 by 2 kT, that will give us a kinetic energy of one particle. So what I should do, this kinetic energy, after getting the kinetic energy, I'll multiply by n, where n is the total number of the particle in which we calculated. It was 1.1. The previous part we calculated, that was 1.1 into 10 to the power 23. So we multiply our answer with 1.1 exponent 23. So we'll get the total energy of the total kinetic energy of all the air particles which are expelled. Is it clear? Any doubt in this? The next we have explain why internal energy of air can be taken as a total kinetic energy of the air molecules. So like why we can say that, because we know internal energy is what? Internal energy is the sum of kinetic and potential energy. So the internal energy is refers to sum of kinetic energy plus potential energy of the particle. The thing is what they said, why the internal energy of air can be taken as a total kinetic energy of the molecule. Like we ignore the potential energy and we can say internal energy is kinetic energy. Because what is the reason for that? Ideally, the particles in air, like example, if the particles are there, they have the potential energy is mgh, mass into gravity into height, and the mass of the particle is negligible. Like when I say, if you compare the mass of air does have mass, but it is very light. So mass of the air particle is negligible, or which can be considered as negligible. So if we consider the mass of the air particle as negligible, or we don't give them a weightage, it means the potential energy will be negligible. And if the potential energy is negligible, we can say the kinetic energy will be equals to internal energy. So how to write the answer here, how to get score the 2 marks? First thing you will mention the internal energy is a sum of kinetic and potential. The second thing you will say the air particles have a negligible mass, so we can consider that their potential energy will be negligible, or the internal energy will approximately equals to kinetic energy. Is it clear, the part 3? Any doubt in the part 3? No, if the mass is, why we are not ignoring, if you compare half mv square and you compare mgh, the speed at which the particles are moving is very high, but the change in position of the particle, example, the mass is negligible, and when the particle of a gas move, the distance which it move is also negligible in the container or in the lungs. Like the change in height in the lungs is negligible. It might be like 10 centimeter, 15 centimeter. So this change in height and the mass both are negligible. That's why we ignore the potential energy of the particles. But why we consider the kinetic energy? Because the particles are moving, still moving and with a considerable speed. But in a potential energy, both the mass and the heights are negligible. That's why we ignore them. Next is air is a mixture mainly of a nitrogen and oxygen. Oxygen molecules are more massive and nitrogen is 80%. Compare the mean speed of oxygen molecule because the temperature is same. This is the same example which I gave. Like example, if the molecules are like, if the different types of gases in a same container at the same temperature, so they will have the same kinetic energy. The kinetic energy of the particle will be same, but because the oxygen molecules are massive or they are having more mass, so the oxygen molecule will move at a lower speed. So here we'll say at same temperature, like the kinetic energy of the oxygen, I'm writing in terms of statement, kinetic energy of oxygen will be equals to kinetic energy of the nitrogen. But because the nitrogen, oxygen molecules are heavier, so they will move at a slower speed. Nitrogen molecules are lighter, so they will move at a higher speed. Half mv square will be same for both of them. The next is the pressure exerted by the air in a sample is partially due to oxygen molecule and partially due to nitrogen. Explain why nitrogen molecule would account 80% of the pressure. Like in the lungs, we have about 80% nitrogen and 20% is oxygen. Other gases are there, but like the question is why the pressure is mainly due to nitrogen rather than oxygen. So we have this equation, we have the general gas equation, PV is equals to NKT. Okay. So you can see the volume of the lungs is same for both nitrogen and oxygen. It's not changing. Temperature is also same. This is constant is also same. So what it means the pressure is directly proportional to the number of the particles. And because 80% nitrogen means that nitrogen particles are more or greater number of the nitrogen particles as compared to oxygen. That is why the nitrogen will contribute to more pressure. Like let's say 100,000 Pascal is there, the pressure from inside, but 80% of the pressure is due to nitrogen because it has a greater number of particles. So how to write in terms of the statement? First thing you will say that because the gases are in the lungs at the same volume and at the same temperature. So when volume and temperature are same, the pressure of a gas is directly proportional to number of the particles. The nitrogen is having greater number of the particles. That's why it contributes to a greater pressure or more pressure as compared to that of other gases or oxygen, you can also say. Is it clear, this part B2? Any doubts? Yes, I'll repeat. We know the pressure exerted by the gas. We know the pressure exert according to this equation, PV is equals to nRT or NKT, capital N and Boltzmann constant T. The volume is same for both gases because they're in the same container, or you can say lungs. The K is also constant. The temperature is also constant. The temperature is also constant, as they mentioned. So it means the pressure depends on the number of the gas particle. So greater the number of the gas particle, greater the pressure exerted by the molecules. So in the lungs, there are 80% of the gas particles which are nitrogen. That's why the pressure contributed by the nitrogen will be higher than the other gases. So how to score 3 marks? First thing you'll mention, the volume and temperature as like pressure exerted by the gas depends on pressure exerted by the gas depends on volume, temperature, and the number of the particles. But volume and temperature are same for both gases. Nitrogen is 80%, so greater number of the nitrogen molecule. That's why higher pressure it will exert in the lungs.